Hi, in this video I'm going to give you a brief tour of our web app Argus and showcase some of its new features. Argus, which stands for Aerial Rescue and Geospatial Utility System, is a software developed by a small team of researchers at the Westphalian University of Applied Sciences in Gelsenkirchen as part of the German Rescue Robotics Center research project. The primary purpose of Argus is to document UAV flights, mainly mapping flights, and well-structured reports and generate auto-mosaic maps from these images. Additionally, it analyzes those images using our AI classifiers. Argus is intended for use in drone units of rescue services and fire brigades. Argus features an overview page where you can see all your flight reports. They can be unstructured or grouped under group projects. Grouping reports is useful if you have multiple flights during a mission and want to organize them together, or if you want to observe changes in the site between individual flights. For example, this group report containing flights from a wildfire training allows you to see how over time more and more of the field got burned. You can open a report either directly from within a group report or from the project's overview. On the overview page, you can also generate new object groups and new reports. Let's do this together with a small example dataset. First, we create a new project, give it a title and description, and then create a new report within this project, also with a name and description. Once the report is created and opened, we can upload the images. Argus automatically detects thermal or infrared images and checks if the temperatures are embedded in the file, as it is the case with drones like the DJI M30T. If not, temperatures need to be estimated based on the color map and min-max temperatures. In this case, a pop-up like this one will appear asking for the user's input. There are several options for mapping the images. Argus has its own fast mapping algorithm that maps the images purely based on their GPS coordinates. This is a very fast and robust approach. However, if you want a more detailed image, you can additionally use the popular drone software WebODM, which is integrated with Argus. Keep in mind that WebODM can take significantly longer and may sometimes fail with tricky datasets, especially with infrared or thermal images. Once we start the processing, the report appears and provides details of the flight, the UAV, and the current weather at the flight location. The fast mapping is already done, and the map gets loaded into our report. We can interact with the map and use the slideshow to examine our images closely, using the magnifier or overlay IR images if available, and read out the temperatures. If we want to, we can adjust the color scheme to quickly show relevant peaks in temperature on top of the RGB image. The images are also structured in a gallery view at the bottom of the report, grouped by RGB and infrared images. If, like in our case, panoramic 360 degrees images were added during the upload, they can be found in their own tab as well. Clicking on them opens an interactive panoramic viewer. You can watch them in full screen and take a look around. If we check the current progress, we can see that the WebODM maps are still processing. Since Argus is a web app, it can be opened in a browser from any device within the local network. This allows you to run the server on a more powerful machine to process the data faster. We'll wait until the maps appear in our report and then continue. After waiting for around 5 minutes, the mapping has finished and the orthophotos can be overlaid on the map. As you can see, WebODM created a cleaner looking RGB image, but failed to properly map the infrared images. Since WebODM creates a sparse 3D point cloud for the fast orthophoto calculation, we can also open that and get a 3D view of our site. If you want a more detailed 3D model, you can calculate a better version with WebODM by simply pressing this button in the report. Generating a 3D model does take some time, so I will just show you an example of an already processed flight. Integrating WebODM allows us to easily generate dimensionally accurate 3D models based on our flight data, which can be used to measure things like distances or areas, thanks to WebODM's built-in tools. The last feature I want to showcase is our AI object detection. We can run it to detect people, fires, or vehicles. If you are running it for the first time, ensure you have an internet connection so our AI model can be downloaded. Let's take a look into this report where the detection is already finished. Argus displays almost all detections made by our AI, even those with lower confidence, meaning detections where the AI is not sure if there might be an object or not. You can filter the results by adjusting the confidence threshold. The detection can be visualized and filtered further in the map and on the images in the slideshow. Down here, you can edit the detections, delete false detections, or add new ones manually. A new feature will soon allow you to send these detections to other programs as services. This concludes our tour of Argus. If you want to explore it yourself, you can check it out on GitHub.